Kepler's laws. Since ancient times, planetary motion had been observed by astronomers. Before Galileo, all observations about the positions of the planets were made with naked eyes. By the 16th century, a lot of data was available about planetary positions and motion. Johannes Kepler studied the data available at that time. He found that the motion of planets follows certain laws. He stated 3 laws describing planetary motion. Before we proceed to study these laws, let us first understand what is an ellipse. Do you know? An ellipse is the curve obtained when a cone is cut by an inclined plane. An ellipse has 2 focal points. F1 and F2 are 2 focal points of the ellipse shown here. The sum of the distances to the 2 focal points from every point on the curve is constant. Here, A, B and C are the points on the ellipse. Thus, AF1 plus AF2 is equal to BF1 plus BF2 is equal to CF1 plus CF2. After learning what is an ellipse, let us now study Kepler's first law. Kepler's first law. The orbit of a planet is an ellipse with the Sun at one of the foci. The elliptical orbit of a planet revolving around the Sun is shown here. The position of the Sun is indicated by the letter S. Kepler's second law. The line joining the planet and the Sun sweeps equal areas in equal intervals of time. AB and CD are the distances covered by the planet in equal intervals of time. After equal intervals of time, the positions of the planet starting from A and C are shown by letters B and D respectively. This means that the straight lines AS and CS sweep equal area in equal interval of time, which means that area ASB is equal to area CSD. Kepler's third law. The square of its period of revolution around the Sun is directly proportional to the cube of the mean distance of a planet from the Sun. Thus, if r is the average distance of the planet from the Sun and t is its period of revolution, then t square is directly proportional to r cube. That is, t square upon r cube is equal to the constant, which is equal to k. This is equation 1. After studying about ellipse and Kepler's laws, now it's time for a question-answer session. As shown in the figure, if the area ESF is equal to area ASB, then what will you infer about EF? If the area ESF is equal to area ASB, then the speed of planet between A and B will be maximum, whereas the speed during E and F will be minimum. Kepler obtained these laws simply from the study of the positions of planets obtained by regular observations. But Kepler could not explain why do planets obey these laws. In the next part of this chapter, we shall understand how these laws help Newton in the formulation of his theory of gravitation. Come, let us now move to the next part.